Miscellaneous transformations. Objective, by this lesson you should be able to graph functions, do translations, apply translations to given points to find new coordinates. So this lesson is basically a summary of all the other transformation lessons that I'll put together. So let's start off here. Consider f of x equals 1/2 x plus 1 on separate axes to graph all this stuff. So let's graph the first one first. So let's be our f of x. Like this. We'll graph in blue. So 1/2 x plus 1. So we're going to start at 1, and we're going to go up 1 over 2. So a graph that looks kind of like this. Now, for the sake of it, I'm going to add points, because it's always helpful to add a couple points. So this is 2, 2. Okay, that's the original function. Now look at what a does. A wants us to graph the same thing, but y equals f of x plus 2. So, remember what that means? Inside x opposite. So inside x opposite. So we're going to do the opposite. We're going to go 2 to the left. Or on our x, we're going to subtract 2 from all the values. So anyway, I want to think about it. So the exact same graph. We're going to move 2 to the left. So if you get every point, move it 2 to the left. So 0, 1 becomes negative 2, 1. 2, 2 becomes 0, 2. You get the exact same. Then we get the graph moved to the left too. So there are two ways to think about it. Either get your x value, subtract 2, so that makes that negative 2, 1, and that makes that 0, 2, or just get your points and go left 2. You get that graph. This is A. B. Alright, look at this one. So what's happening there? It's on the outside. Outside y follow. So on our y, we're going to go plus 2. We're just going to think we move up 2. So again, you can get all your points and move it up 2. So we know what you're doing. You can like this. Or just add 2 to your y. So it becomes 0, 3 and 2, 4. So into that effect. That's B. C. Okay. So C is probably a little more the most complicated. Y equals 2 to f of x. So remember what happened there? That's on the outside, so it's a vertical stretch, a factor 2. Or you know way to think about it? On your y, just multiply them by 2. So multiply all our y values by 2. And with stretches, that's usually the easiest way for me to do it. So 0, 1, just multiply your y value by 2. That point becomes 0, 2. And then the point 2, 2, multiply your y value by 2, it becomes 2, 4. So it looks like this. So like that. So that's y equals 2x, or 2f of x. And then the last one here, D. Running out of space, so let's put it here. Let's see, on this one we want y equals negative f of x. So look where the negative is. It's on the outside. So this is a vertical flip, because outside to y, so you can flip vertically. Also known as the x-axis flip. Another way to think about it, on your y, we're just going to multiply it by negative 1. So another way to do it, just get out your points and multiply your y by negative 1. So 0, negative 1, and 2, negative 2. And you get a graph that looks like this. Here we go with that one. Okay, the next one. Consider the function f of x. What function results if y equals f of x is reflected in the x-axis, then translated through 3, negative 1, then stretched vertically with scale factor 2. So we want to know, it's basically what we're doing. So what's basically going on here is this. The most generic version of a function is this. Right, so that's our most generic function. Y equals a f of b x minus h, for parenthesis, plus k. Where, right, everything on the inside is x values and do the opposite operation. Anything on the outside, the y values, and you follow what it says. So if it says plus, you go up, minus, you go down. If it says multiply, you multiply. Inside operations, right, it says plus, you do minus, minus, you do plus. If it says multiply, you multiply the reciprocal, or you divide. So inside x opposite, outside y follow. So what they want to do is fill this out using these things, using the stuff we found out here. So the first thing I'm going to do is this. Remember, when you see a vector translation like that, that's just the translation. This is your x value, and this is your y value. So in my answer here, I'm going to put y equals f of x, inside opposite, so x minus 3, and outside follow, so minus 1 on the outside. Right, that's essentially my h and my k here. So 3 goes here, -1 goes here. Now how about the stretch? Well, it's stretched vertically with a scale factor 2. So remember, vertical is the outside y vertically. So I'm put it, and the outside you just follow, so you just put 2 on the outside. There you go. Now luckily we don't have a horizontal stretch, so that would have to go here. So you have to put a parenthesis and then the 2 on the outside, right? You're not supposed to combine it. There's one last thing though. Reflected across the x-axis. So where's that negative go? Does it go on the inside or the outside? Now it's a little tricky. It's in the x-axis, so what they mean is, here's your x, here's your y. They want you to reflect it across the x-axis. So you're flipping it upside down, which makes it a negative on the outside. It's a vertical flip. So put the negative on the outside. And that is your answer there. Right? That's what all this stuff did to that. Okay, B. B's kind of going backwards. It's like, here's our finished product. What translation did you do? We'll start with translations, right? -1 and -2, right? Those are stuff being added or subtracted, that's the translation. So we're moving right 1 and down 2. So you can say x horizontal, not x, horizontal translation right 2, right 1, sorry, and then vertical translation what was that? Down 2. So you can write it, that's one way to write it, or you can also write just what they did up there. You could say that y is being translated through the vector -1 and 2. Right? Inside, positive 1 and 2. Sorry about that. 1 and -2, there we go. Right? Inside x opposite, so instead of -1, it's a positive 1, and then outside y follow -2. So you can write that instead. So either one's fine. How about my x and y stretches? There's both, right? There's a vertical stretch of 3 and a horizontal stretch of 1/2 inside x opposite. Remember, so we flip it when it's on the inside. So we're going to write that. Vertical stretch factor 3 and horizontal stretch factor 1/2. Right? Again, outside y follow. So vertically we're just multiplying by 3. Inside x opposite. So we don't do opposite operation. We don't multiply by 2, we multiply by 1 over 2. Or divide by 2. So there you go. There's that part. So on to the next one. Consider a function of x. Find the function which results in y equals f of x if is stretched vertically with a scale factor 1/2, then translate through -2, 1. So it's like the same question. Right? So what's going on here, I started off with first, right? So x is the top, y is the bottom. So remember, x inside x opposite, so we're going to do f of x plus 2, and then plus 1 on the outside. From that, right? Inside x opposite, so plus 2, outside y follow, plus 1. And then vertically, so that's on the outside, scale factor 1/2. You just follow what it says. So there we go. If that was horizontally, I would have to flip that and make it a 2. But since it's y, it's vertically, just follow what it says. So there we go. Last one here. For the graph, given the sketch graph of this. So they want to sketch all these graphs. I'll just kind of do on the same picture real quick. So what does this one do? Oops, sorry. Notice how there's my graph of x. This is the 2's on the outside, so we're going to move up 2. So all our points we're going to go up 2. We're going to go to 5, up here. So it'll kind of like this. And I just realized it's going to get really messy if I try to do that all in the same graph. So we're just going to, I'll just put little key points and do like a sketch. Kind of like that. So let me erase this. Alright, we moved up 5 on that one. Or, think about it, get some key points. And all we did was add up 2, sorry. I add 2 to all my y values. It become -2, 2, 0, 5, and then 2, 2. B. Look at the negatives on the outside. So this is a vertical flip. Or another way to think about it, multiply all your y values by -1. So we're doing B. Right? If I multiply all my y values by -1, I get -2, 0 still. I get 0, -3, and I get 2, 0. So it's be kind of like this. So this is kind of doing a sketch. We're flipping it upside down. So kind of like that. I would flip our graph upside down. C. Negatives on the inside now. So this is a horizontal flip. Or another way to think about it is multiply your x values, since it's on the inside, by 1 over -1, or just -1. So that becomes, so you kind of flip it this way. So it's going to look kind of like this. So it's going to kind of look like this. Right, so you flipped it left and right. So it looks, so you kind of flip it across and you look at something like that. Right, notice how it bounces off the 2 and over here bounces the -2. Okay, and last one. I guess I'll do it in the green, so all I got left. Oh, I got some red. Now this one, notice how the inside, so remove left 1, or this on your x values, subtract 1 from all the x values. So we're just moving left 1. So this point comes over here, this point comes over here, this point comes over here. So this will come like this. Right, this little sketch, but it all moved over left 1. And that's the lesson.